Okay, here we go. All right. Now, as I mentioned, Monday you had a book assignment on solving quadratic equations by graphing. We actually graphed the parabola and we were looking for the x-intercept. Wherever it had an x-intercept was a solution to that quadratic equation. So that was like the second method you learned for solving a quadratic. The first method was factoring. We solved quadratics by factoring. Okay, now today we're going to learn a third method for solving quadratics, and then there's two more after this. Today we solve them by using square roots. So if you can take a look in your notebook, it's down in your notes, 9.4, use square roots to solve quadratic equations. Now, this only works with certain type of quadratics. You have an ax squared and a c term. You don't have the bx term. What we have to do is take the equation and isolate the x squared so that it says x squared equals some number, which we're going to call d. So the equations, once you take these equations and you isolate x squared, it's going to look like x squared equals d. And here's what we know. If that d is positive, you are going to get two solutions to your equation. You're going to get a plus and a minus the square root of d as your solution, your two solutions. If the d were equal to 0, you would just have x squared equals 0, and you're just getting the one solution, which would be 0. If the d is negative and you get x squared equals a negative, can you think of a number that'll square and give you a negative? Can't do it, can you?
No.
So you would get no solution. It would be empty set. All right, so those are the three cases we're talking about. So I have one type of quadratic equation that's going to end up looking like x squared equals d. And then I'm going to erase this and put another type where we have a binomial square equals a number. And we solve it by square rooting. You'll see those coming up. Okay, so let's start with 2x squared equals 8. So what's the first step? Isolate x squared, right?
Yeah.
So what is this going to give us?
X squared equals 4.
Right. You get x squared equals 4. And now if x squared equals 4, you're looking for all numbers that'll square and give you 4. What numbers will square and give you 4?
2 and negative 2.
2 and negative 2. So anytime you have x squared equals a positive number, you get plus and minus the square root of that number. And the square root of 4 is 2. So you get x equals plus or minus 2. So that's solving by square rooting. Next one. X squared minus 18 equals negative 18. Isolate x squared. So what are you going to do? Add 18 to both sides, right? And what does that give us? Somebody,
We
I
can't
can't see the
it, Mr.
problem. We
Ed.
can't see it.
you can't see it?
No. There we go.
Okay, so if x squared minus 18 equals negative 18, what is x squared going to equal?
Negative or 0.
0. You're going to add an 18 to both sides. And if x squared equals 0, what does x equal? Simply 0. You don't write plus and minus 0. They're both just 0. So that's the second case. When d was 0, you got one solution, 0. Can you see this problem?
Yeah.
X squared plus
no,
12
yeah.
equals 5. So what are you going to do to both sides?
Subtract 12.
12, and that gives you x squared equals negative 7. What's the solution? What number squares and gives you negative 7?
No solution.
Anybody?
No solution.
No solution.
No solution. You can't square a number and get negative. So this is empty set. That's if d is less than 0, you get empty set. Okay, so that's all we're doing here. Now we get some different type of fractions here. 4x squared equals 9. X squared's going to equal 9 over 4. And so x equals plus and minus the square root of 9/4, which would be what? 3 halves. So you end up with 3 halves, plus and minus. Okay? Here's the next one. 3x squared minus 11 equals 7. So you're going to add 11, get 3x squared equals 18, divide by 3, and get x squared equals 6. Now what do we get? We get x equals plus and minus the square root of 6, radical 6. So when you solve by square rooting, you don't always get a whole number or a fraction. Sometimes you get these radical numbers. And if we wanted to, we could go to our calculators and round that to the hundredths for its decimal value. Get your calculator and look up the square root of 6. Look at your buttons and look for the square root button and hit the square root of 6. What do you get? Somebody do it. What's the square root of 6?
Mr. H.
2.4494897
So
427.
2.449,
48974.
2.45. So that would be approximately plus or minus 2.45. Plus or minus 2.45. All right? So when you have the square root of a non-perfect square, sometimes we convert them to decimals and we'll round to the nearest hundred. What's this last problem here? 9x squared equals 100. X squared equals 100 over 9. So what does x equal? Plus or minus what? What's the square root of 100 over 9? Come on. What's the square root of 100?
10.
10.
10. What's the square root of 9?
3.
3. So you get plus or minus 10/3. Okay, last two problems. X squared plus 4 is 14. X squared would equal 10. X would equal plus or minus the square root of 10. And again, that's the exact answer, square root of 10. The decimal answer is an approximate answer, but you could go to your calculator and look up radical 10 and round it to the nearest 100 if we wanted to. If I said I wanted a decimal answer, if I don't want a decimal answer, you leave this. You leave plus or minus radical 10. And this last one, we're going to isolate x squared. We're going to add 7 and get 9, and then get x squared equals 9/2. So x is the square root of 9/2, which is 4.5. And so if you get x equals plus or minus the square root of 4.5, you'd want to go to your calculator and hit the square root of 4.5. And that's going to be 2 point something.
1, 2.
Right. Do we see this?
Yep.
We know what we're doing.
Yep.
These are all equations in which you can isolate x squared and get x squared equals some number d. And then x is equal to the plus or minus the square root of d. Or it's 0 or it's no solution, depending on d. Okay. So I can get rid of this, right?
Mm-hmm.
Yep.
We all have this
Sure. Yep.
in our notes. Now let me show you one other type of problem you're going to get into. And this type of problem comes into play on Friday when we do what's called completing the square. So the first one here, x minus 3 quantity squared equals to 36. We'll take a look at that. And 4 times x plus 2 squared equals 100. And then number 3, 6 times x minus 4 squared equals 42. Okay, and then 5 times x minus 2 squared equals 25. And then 3 times x minus 5 squared plus 10 equals 19. All right, this is the other type of problem you can solve by square rooting. Okay? When you have a binomial square all by itself. This is going to be all by itself. So you'll see what we do in a problem like this. We have to isolate the binomial square. And so if we have x minus 3 squared equal to 36, you're going to square root both sides. When you square root both sides with a positive number, the left side will give you x minus 3. The square root of x minus 3 squared is x minus 3. And then that equals plus and minus the square root of 36, which is 6. When you square root both sides of an equation, you have to get a plus and minus solution on the right side if it's positive. And so now we want to solve for x, so what are we going to do? We're going to add 3, aren't we, to isolate x. And so x ends up equaling 3 plus or minus 6. What two numbers are those? 3 plus 6, 9, 3 minus 6, -3. Those are your two solutions. And you can check them out. If x equals 9, you'd have 9 minus 3 is 6, and 6 squared is 36. If you had x equals -3, -3 minus 3 is -6. And -6 squared is 36. So we can see that 9 and -3 are the two solutions. All right? Do we see this?
Yep.
So it's a little different than the first type of equations where we isolated x squared. Now we're going to isolate binomial square. So in this problem, what's the first step? What do I need to do first?
Divide by 4.
Divide by 4. So you're going to knock that 4 out, knock that 100 out, and make it a 25. And now you have x plus 2 squared equals 25. Square root both sides. You're going to get x plus 2 on the left equals plus or minus the square root of 25, which is 5. And then you're going to subtract 2 on both sides. So that gives you -2 plus or minus 5. And so you get -2 plus 5, which is 3, and -2 minus 5, which is -7. Those are your two solutions. Okay? So the first thing we had to do was isolate the binomial square. We divided by 4. Then we square rooted both sides. Got the x plus 2, got the plus or minus 5. And then you isolate the x. You subtract the 2. And then you simplify this expression with the plus or minus. Can you see this bottom problem? Do you see it?
Yes.
What do we do first? What are we doing first here?
Divide.
Divide by
what?
6.
Divide by 6. So you divide by 6, you're going to get rid of that. Divide by 6, that's going to become a 7. And now you got x minus 4 squared equal to 7. And so then you're going to get the x minus 4 equaling plus and minus the square root of 7, which we leave as radical 7. We're not going to change it to a decimal. Then you're going to add 4 and get 4 plus and minus radical 7. And those would be considered the two plus radical 7 and 4 minus radical 7. And if you wanted to know what decimals those were, you would look up radical 7 and take 4 plus it and 4 minus it. And you would get the 2 decimal for this problem. But if we want exact answers, we leave radical 7. So you're getting that binomial number, 4 plus radical 7, and the number 4 minus radical 7. Okay, up here, we're going to start by dividing by 5. That'll cancel that out. That'll make that a 5, 25 over 5. And then you're going to get your x minus 2 equals plus or minus radical 5, and then x equals 2 plus or minus radical 5. And that's the exact solution. 2 plus radical 5, 2 minus radical 5. Okay, and this last one, what's the first step?
Subtract 10.
Subtract 10. And then you get 3 times x minus 5 squared equals 9. Then you divide by 3 and get the x minus 5 squared equal to 3. And then the left side becomes x minus 5 when you square root it. The right side plus or minus radical 3. And so the x is 5 plus or minus radical 3. I don't know if you can see that. Get that in your notes. All right, that's it. Those are the 2 types of problems you're going to solve tonight by square rooting. So you had solved by factoring, solved by graphing, and now solved by square rooting. Okay? Any
Okay.
questions?
Did you want us to turn in that worksheet?
Yes. So yesterday you did worksheet 9.3. Make sure you turn that in. All right, that worksheet 9.3.
When should we turn
Tonight
that
you're
in
doing
by?
quiz 9.23. So make sure you get that done today so you can turn that in tomorrow. All right, and once again, I'll see you Friday. This will be one of the few Fridays we'll actually have class. But tonight you have the quiz. Tomorrow you have a Delta math assignment on solving by square rooting. And then Friday we get into the new material called completing the square.